Hello, everyone. Welcome to BlockLeap Academy. Today, we are going to see something very, very important, which is called hashing. And it's basically the backbone of blockchain and Bitcoin. And it's absolutely paramount if you want to understand what cryptocurrency is about. So cryptography, hashing, is something we're going to see today. So really, let's go to a quick definition, which is not, it looks like complicated, but it's really not. Basically, hashing is to apply a hash function in order to encrypt data. So it's in a way, scrambling raw information into a hash value, which is always a fixed length. This is very important to understand, okay? So I always give this example. Here you've got original data. Imagine you've got like 100 books, 10 books, and you want to hash them. You want to encrypt their content. What you are going to do, you are going to type these 10 books and you are going to put these 10 books in this, I said before, this Enigma machine, which is a good encrypted machine. And you've got an algorithm, which is in the case of Bitcoin is called SHA-256. You've got, we will see it later, SHA-256. And this algorithm is going to scramble, okay, all this data is going to create one hash value, which is a fixed length, which is only 250 bits of fixed length. So, which is very important to remember, the fact you've got 10 books, which is like long. Imagine it would be a long string of letters. Now you've just, after the hash function, you've got only a fixed length. Imagine you want to put 1,000 books. You will have the same. You will put the 1,000 books in this machine. You will have the hash function working, and then you will have a fixed length of 250 bits of numbers. Okay, so this is what hashing is about. All right, and then you have to remember what we said before, that this hashing is always a one-way function, meaning that you can't go back. Once the hash is done, when you've got the hash value, it's impossible to go back and try to find the original data. This is what we call it a one-way hashing, okay? So this is more or less what it looks like, okay? This SHA-256. is when you've got like a raw number and letters all together. This is what your hash result looks like. So I explained that the cryptography and the SHA-256, which is a 256 bits fixed length, is the result of the hash function. So when we say deterministic is very, very important, meaning that, as I said, you can't go back. Once you've got the hash done, okay, you can't, by any means, you can't go back and see what was the original data. I always give this example. Imagine you've got a billiard table. Imagine you are strong enough to kick the ball, to strike the ball, and the ball is bouncing 100 times all around the table. And when you arrive, you see the ball where it is now. So if you just arrive when the ball just stops, it would be impossible for you to find all the bounces of this ball. You can't find them. It's impossible. And you can't therefore find where was the ball at the very beginning. This is what a one-way hashing means. And deterministic means that if you have, imagine you can kick it again. So you put the ball again in the same place, you kick it, you strike it as in the same way, it should be, so if you have the same parameters at the beginning, you should have exactly the same pattern. This is deterministic means. And this is very important because if you, with the same data, you reproduce, you put that in the machine, you will always have the same result. This is very important. But you can't go back and find out what is this original data. So it's really important. So in order to find it, you need this pair, you need these keys, all right? Very important. So what are they used for? This is important. So why do you need cryptography? I think now you understand why you need it. Again, Bitcoin is a cryptocurrency. You need it in order to encrypt, but as well, you use it in order to do two other things inside the blockchain, okay? So the task this SHA-256 is doing is like, one, checking the integrity of messages, meaning it's validating, it's checking that all the transaction or all the movement inside the blockchain were not hacked. They are valid, they were not tampered with, okay? And the second one is for authentication. So validation, authentication. Authentication is more for the miners, and we are going to see that later on. So in a nutshell, when you've got this SHA-256 hashing mechanism, is doing several things inside the blockchain. And one of the two of them, the most important, are validation and authentication. All right. So let's go now and recap, right? So one, hashing is the backbone of blockchain security. Without hashing, you don't have security. Then you can have the double spending happening, which is hacking and creating new coins, okay? Which is what Satoshi Nakamoto, with proof of work, which is the applying all this technology, is about, all right? Every single transaction inside the ecosystem has been hashed, and every transaction has a hash, okay? And again, I repeat, the hashing is also used to double check that no one hacked the transaction when they were creating. And then when the miner is putting the transaction in a block, the miner have to double check going back and see if the hash they are putting in the box, in the block, are valid, okay? All right, so I think I'm done.